See the next question. Newman projection of staggered conformation is. So different conformations are there. First, different projections. C2H6 ethane. So Newman Sahor's. So Sahor's projection, Newman's projection. Sahor's projection means CC bond line indicates on the paper, remaining hydrogens are also on the plane, same paper. So these two are A and C. A comma C are Sahor's projection. This indicates based on scientist Sahor's projections. B and D, this carbon indicates nearer to the observer. Back circle carbon indicates away from the observer. Circle indicates carbon. This indicates this joint of 3 bonds indicates also carbon. It is nearer to the observer, one carbon. Circle indicates away from the observer. So next, 3 hydrogens, CH3, single bond CH3. So C2H6. Very easy, very easy. Staggered, eclipsed and Gaussian. Three main formations are there. If hydrogen is exactly backside of CH bond, this CH bond is exactly backside of CH bond, then that is called eclipsed conformation. So if CH bond opposite to CH bond, same atoms are opposite to the opposite side, then it is called staggered form. So it is eclipsed form, it is staggered form. In this again Gaussian forms are there. So it is highly stable form, staggered form. Eclipsed forms are again classified into fully eclipsed and partially eclipsed. Fully eclipsed is highly energy and least stable. Partially eclipsed is when compared to fully eclipsed more stable. That is we will discuss any another bit. Staggered is highly stable. Eclipsed form is highly unstable, least stable. So Newman projection of staggered conformation is option D. These two are B comma D are Newman projection. Very easy, don't confuse. Okay, next. Identify the correct order of reactivity of the following haloarenes: benzene ring and halogen. Haloarenes. And treatment with NaOH. NaOH and treatment with NaOH means Cl minus is replaced by OH minus. Nucleophilic substitution. Cl minus is replaced by OH minus, in which it is highly possible. Cl minus replaceable means here positive charge is formed. When positive charge is more formed, if this aryl ring, benzene ring contains electron withdrawing groups on ortho and para positions, then the OH, this Cl minus is easily replaced by OH minus. Understand? If benzene ring contains, that means if halobenzene ring contains electron withdrawing groups at ortho and para positions, then this Cl minus is easily replaceable by OH minus. So because electron density decreases, Cl minus is replaced and positive charge is formed, OH minus is attacks. If the number of electron withdrawing groups on benzene ring increases, reactivity nature increases. So which one has more number of electron withdrawing groups? So here only one, here 3, here 2, here which one has more number of electron withdrawing groups? 2. So 2 greater, so maybe CRD 2. Next 4. Here 2 electron withdrawing groups. So next 2 greater than 4. Next 1 3. So in these two, which one has more reactivity nature? If NO2 is present at ortho or para, reactivity nature is more. So para more. So at meta position is very less. If electron withdrawing group is present at meta position, reactive nature is less. So 2 greater than 4 greater than 1 greater than. So answer C. So the concept is number of electron withdrawing groups withdrawing groups increases, reactivity increases. Okay, not this. So which one of the following reactions gives the product with less number of carbon atoms than the starting material? So very easy. Different reactions are there. So first one, RX, alkyl halide, in the presence of sodium ether, dry ether. So sodium in the presence of dry ether alkyl halides forms alkanes, higher alkanes. So it reacts with again alkyl halide in the presence of 2 moles of sodium. It forms RR plus 2NaX. It is Wurtz reaction. You know that Wurtz reaction. So higher number of alkanes are formed. 1 carbon taken, 2 carbons containing compound is formed. So it is wrong. Next B, RCOONA. It is sodium salt of carboxylic acid. RCOOH, when reacts with the sodium, it forms RCOONA. It reacts with NaOH plus CaO. NaOH plus CaO means soda lime. When salt of carboxylic acid reacts with the soda lime, decarboxylation takes place. CO2 is removed as Na2CO3. So Na2CO3 is removed. So then RH is formed. RH plus Na2CO3. So here RC, but here only RH. That means 1 carbon less. Whatever you have to take here R, either R means CH3 or C2H5 or C3H7, whatever alkyl group. But the product is RH, that means 1 carbon less. That carbon removed as like Na2CO3. So 1 carbon less than the parent compound here. So answer B. So next you will also see, check C, RCO2K, RCOOK, and electrolysis with water. And electrolysis RCOOK forms R, single bond R. Again reacts with another mole of RCOOK. RR plus CO2 plus KOH is formed. So next D, RX, alkyl halide. Alkyl halide reacts with zinc and HCl. It forms reduction. RX, Zn plus HCl, RH is formed plus HX. So option is B is correct. Here same number of carbons. Here also more number of carbon atoms. Here less number of carbon atoms because here 1 carbon less. Here same number of more number of carbon atoms. So answer is RCOONA. Very easy. 22nd question, 4 bits are covered. So okay, very important. The total number of aromatic compounds from below is very easy. Aromatic compounds means it follows Huckel's rule, 4n plus 2 Peltrel's rule, and it is planar. So NH2, it is aromatic because 2 2 2 6. 4n plus 2 Peltran's rule follows. 4n plus 2 is equal to 6, 4n equal to 4, n equal to 1. So it follows aromatic, Huckel's rule, aromatic. So 2, 4, 6, 8, 10. 5 double bonds, that means 5 pi bonds, 5 into 2, 10. So 4n plus 2. 4n plus 2 is equal to 10, 4n is equal to 8, n is equal to 4. So it is also aromatic. So it is 4n plus 2 is equal to 4, 4n is equal to 2, n is equal to 2 by 4, 1 by 2. So it is anti-aromatic because it follows 4n rule, 4n rule. 4n is equal to 4, n equal to 1. So if it follows 4n rule, that is anti-aromatic. It is not in conjugation, so it is not aromatic and not anti-aromatic. So next, it is here nitrogen contains lone pair of electrons. That lone pair of electrons not involved in conjugation. Only these pi bonds are involved in conjugation. 4n plus 2 is equal to 3 pi bonds means 6. 4n is equal to 4. So n is equal to 1. So it is also follows Huckel's rule. So it is aromatic. So how many are aromatic? 1, 2, 3. So answer 3. So option B is correct. Okay, note this. Next question. Arrange the following free radicals in the correct order of their stability. It is CH3 thrice C radical, tertiary carbon radical. These are all radicals, free radicals. Single electron species carbon compounds are called radicals. So it is tertiary. In stability order is tertiary is greater than, secondary is greater than primary. Here how many carbons are attached to carbon radical? 3 carbons. So fourth one tertiary is greater than. Next it is secondary. Third one is secondary. Next it is methyl radical. So second one is methyl radical. So it is methyl radical, not primary. So if this carbon is attached to single carbon atom, that is primary. So it is a methyl radical. Next finally CH2 double bond CH radical. CH2 double bond CH radical is vinyl radical. Vinyl radical is least stable because the radical is present on double bonded carbon atom. If negative, positive or radical directly on the double bonded carbon atom, that is highly unstable. So it is least stable. So answer is 4 greater than, 3 greater than, 2 greater than 1. So it is the answer. Okay, next. Which of the following does not exhibit geometrical isomerism? Same groups present on same side of the double bond, that is cis. If same groups are present opposite side of the double bond, that is trans. So geometrical isomerism are classified into 2 types, cis and trans. If C double bond C contains same groups on same carbon atom, if it is different, same groups on same carbon atom, that is does not exhibit geometrical isomerism. So these 2 type of compounds exhibits geometrical isomerism. So if you observe first A, 2-butene. So it is 2-butene. It exhibits geometrical isomerism. That means cis and trans isomerism. So A is correct. So does not exhibit. Different groups are attached to same carbon atom, same double bonded carbon atom. So it is also exhibits geometrical isomerism. So next C, but 2 different groups, carbon contains 2 different groups. So it is exhibits geometrical isomerism. Last styrene. Styrene means vinyl benzene, C6H5, CH double bond CH2. So it is vinyl benzene. This carbon contains hydrogen and phenyl group, different groups, but this carbon contains 2 same hydrogen atoms. So it does not exhibit geometrical isomerism. So answer is D. So okay, next question. The correct order of acidity of the following compounds. So very easy. ఇంత ఈజీనా అని అనుకుంటారు మీరు. ఆర్గానిక్ చాలా ఈజీ, బిట్ అలా చూసినట్టే అలా పెట్టేసి మీరు మార్క్స్ ఈజీగా గెయిన్ చేసుకోవచ్చు. చూడండి, phenol. So when compared to alcohols, phenols are more acidic in nature. So phenols, when their acidic nature increases in the presence of plus A affecting groups, in the presence of minus R affecting A, plus R affecting A, plus M affecting A, minus M affecting A, many are there. So how to find which one is more acidic? So if you observe, if H plus donating nature increases, acidic nature increases. In phenols, H plus donating nature increases, acidic nature increases. When H plus donating nature increases, when the bond between oxygen and hydrogen bond strength decreases. మనకి ఈ బెంజీన్ రింగ్లో విత్డ్రాయింగ్ గ్రూప్ ఉండాలి. సో if withdrawing group is present, then acidic nature increases. If donating group is present, then acidic nature decreases. If donating group or electron releasing group. So electron withdrawing group, electron donating group. Here electron donating groups are there. Here there is no electron donating group. So one is more acidic in nature. If you there is no electron donating, electron withdrawing. That's why it has acidic nature. So 1 is greater. When compared to 2 and 3, ఎలక్ట్రాన్ డొనేటింగ్ గ్రూప్స్ ఉంటే ఇక్కడ నెగిటివ్ పార్ట్ ఎలక్ట్రానిక్ పార్ట్ ఇంక్రీజ్ అవుతుంది. ఎలక్ట్రానిక్ పార్ట్ ఇంక్రీజ్ అయితే ఇది ఈజీగా బ్రేక్ అవుతుంది. ఇక్కడ నెగిటివ్ పార్ట్ డిక్రీజ్ అవ్వడం అంటే ఎలక్ట్రాన్ విత్డ్రాయింగ్ గ్రూప్స్ ఉంటే డిక్రీజ్ అవుతుంది. సో డిక్రీజ్ అయిందంటే ఎసిడిక్ నేచర్ ఇంక్రీజ్ అవుతుంది. సో దాని బేసిస్ నీ రెండింటిని కంపేర్ చేస్తే మనకి మోర్ ఎసిడిక్. నెక్స్ట్, ఐడెంటిఫై ద మేజర్ ప్రొడక్ట్ ఫార్మ్డ్ ఫ్రమ్ ద ఫాలోయింగ్ రియాక్షన్. సో ఫస్ట్, ఇఫ్ యూ హ్యావ్ టు టేక్ ద గివెన్ రియాక్టెంట్, add HCl add. When you add HCl, according to Markovnikov rule, the negative part of the reagent is added to less number of hydrogens containing double bonded carbon atom. So here one hydrogen, here there is no hydrogens. Here Cl, negative part of the reagent is added to less number of hydrogens containing double bonded carbon atom. So hydrogen is added here. So if you add AgNO2 means it has covalent nature. So O minus part is attacked at, here ONO part is negative part, ONO part attacks at this carbon atom. Chlorine is replaced by ONO. So then here MeONO is formed. If in the place of AgNO2, KNO2 is there. If KNO2 is there, KNO2 is an ionic compound, K plus NO2 minus. Directly NO2, here ONO, directly NO2 is attached at this carbon atom. Here NO2 is formed, not ONO. AgNO2 is there, ONO formed. If KNO2 is present, then NO2. Nitrogen is directly attached to this carbon atom. Okay. So answer is MeONO. Option D. Note this.